Hello friends and welcome back. Welcome to my channel. Please subscribe and like. Today's topic is comparison between structural and thermal analysis. So many times we do structural analysis. So when we are going to do a thermal analysis, we think that it may be a different than the structural. But in this comparison, you can see the structural and thermal analysis will look like a similar in the way of performing the analysis, not in the theoretical analysis. Okay, so let's get started. So in the structural analysis, we have different structures to be analyzed for the different loads, different forces, and we will get the deformations and we will get the stresses in that. So similarly, thermal analysis will be on the bodies in which different bodies are connected together, and we will be finding out the temperature at the end of the bodies or wherever there is a requirement. So basically in the structural analysis, we follow the finite element equation as a force is equal to stiffness matrix into displacement matrix. Similarly, in the thermal analysis, we will follow the finite element analysis equation, that is heat is equal to, this is a stiffness matrix. Again, it is a stiffness matrix. So we are noting it as a T because of a thermal, then temperatures. So heat is equal to stiffness matrix in the thermal into temperature matrix. So this is the, if we compare these two equations, it looks like similar. So comparing with the force, heat, stiffness matrix, and displacement versus temperature. So let's get into the deep dive. So in the structural analysis, we use forces as a boundary conditions, applied forces. So similarly, in the thermal analysis, we use heat flow. So its unit is a watt, while force unit is a Newton. Now, whenever there is a condition like we are going to apply the pressure, so pressure is nothing but force applied onto the surface area. So unit becomes Newton per mm square. So in the case of thermal analysis, the heat applied on the surface or any particular region, then it will comes as a heat flux. So its unit comes under watt per mm square. So wherever there we apply the pressure, we can apply the heat flux in the thermal analysis. Now sometimes structures have self weight. So that we will consider as a gravity force. So here in the thermal analysis, some bodies have internal heat generation. So in the case of microprocessors analysis, so during the operation of a microprocessor, they perform, due to the performance, they will get heated. So that will comes under the internal heat generation. So that we can apply using internal heat generation. So it acts like a self weight. So that structure has, it is the self heat generated by the bodies, particular bodies. So internal heat generation. Now in the boundary condition, we use a fixed supports in the structural analysis. So body degrees of freedom will be at that point or at that surface will be get restricted. Similarly, we can apply the temperature in the thermal analysis, which will restrict that body going beyond that temperature or below that temperature. So the heat flow can be calculated accordingly. So some of the partial degrees of freedom where we not all the degrees of freedom are going to get fixed, we apply the partial degrees of freedom. Similarly, in the thermal analysis, we give the temperature connections or we use film coefficient in between the contacts. So this is the difference between the thermal analysis and structural analysis during the experimental or performance. So if you know the structural analysis how to do this, then just learn the theory or background behind the thermal analysis and you are able to do the thermal analysis. So hope you like this short comparison video. Like the video and subscribe for more. Thank you.